Hello everyone. Today in our lesson we will solve the further questions on page 168, 169. Question number 1. Question number 1. The diagram shows a light signal traveling through an optical fiber made of glass. This is an optical fiber and here it's the light that it will travel through it. Now, questions. The first question, A. It says, state two changes that happen to the light when it passes from air into glass fiber at B. Now, if you will look at the arrow that it shows the light, see, the question it says, state two changes that will happen to the light when it will pass from air, here it's air, to the optic fiber, which it's made up of glass. Now, because we have air and glass, so what do we have here? Here we have two different mediums. And as we studied before, we said when a light, it will pass through or it will travel from one medium to another medium or between two different mediums, the light, it will bend. So if you look at now, see, this is the light, and once it enters the glass, what happened to it? It bent. So when it will bend a little bit, now what will happen or what will change? The speed of it and also the direction. See the speed, because two different mediums, as we know, each medium, the light, it travels through it with a specific speed. So this is the first change, and the second one, which is the direction. See this, it was supposed to go straight, but what happened? It bent a little bit, it refract a little bit. So the two changes that will happen are the speed and the direction. B. Explain why the light follows the path shown after hitting the wall of the fiber at P. Now, here what happened? When the light it passed through the glass, now when it reached this point, what happened? It reflect. But how it reflect? Here, what do we call this? We call it totally internal reflect. Okay, so explain why the light follows the path that's shown after hitting the wall, or why it reflects by this way. This is what this, it's totally internally reflected. Answer, it's totally reflected, internally reflected. Number 2, question number 2. In the diagram above, an object, a small bulb, this one, has been placed in front of a plane mirror. Copy the diagram, mark in the position of the image. Here we have object, and when we studied about plane mirror, we said if we want to find the position of the image, we have two ways. We will use the easiest way. The easiest way, it's what? We said we will measure the distance from object to the plane mirror, and we will see how much it is. Let's say here it is, let's say 5 centimeters, an example. So if this from object to mirror, it's 5 centimeters, so also here we will measure 5 centimeters and we will make a dot. This dot, now it's what? This, it is the image. In this way, we can find the position of image by using a plane mirror. On your diagram B, draw a single ray from the object that reflects from the mirror and goes into the eye. Okay, here we have object, here we have eye. This eye will see the object by what? By the mirror. So how this it will happen? There will be a ray. So ray from light, from object to the mirror, and then from mirror will be reflected to the eye. and the direction of it will be by this way, because the light is coming from object to mirror and then will be reflected to the eye. C. An object is 10 centimeters away from a plane mirror. How far is the object from its image? Again, here in this example, we said if you will measure the distance from object to mirror, let's say here we said it was 5. Now the question is how much is the distance from object to the image? The answer will be double. So if here it was 5, so the distance from object to the image, it will be 10. In our question, it says an object is 10 centimeters away from a plane mirror. So the answer will be 20. D. If the object is moved 1 centimeter closer to the mirror, how far it is it away from its image then? Again, let's say here it's 10, okay? If it was 10, now the total distance it is 20. Now if we will minus 1, if here it will be 9, so also here it will be less, okay? If here it's 9, so also here it will be 9. So the answer will be 18 centimeters. Question number 3A. Copy the diagram and draw the path of the ray of yellow light as it passes through and comes out of the glass prism. Here we have this prism and here it's the yellow light. Because now the light, it will travel from air to glass, so two different mediums. So what will happen to the light ray? It will bend. But how it will bend? To draw the ray when it will bend, firstly you should draw this line. We call it normal. When you will draw the normal, now we have a law. It says when a light, it will travel from air to prism, see what will happen here? It will bend toward the normal. Okay, so the direction, it will be in this way, a straight way. Then again, what will happen? Also it will bend in this direction. B. What do we call this effect? What do we call this effect when a light is bending? Okay, bending of light, this effect we call it refraction. C. State why light changes direction when it enters a glass prism. Why the light, it will change its direction when it will pass through the prism. The answer will be light waves, it slow down. Okay, light waves slow down, because as we mentioned also here in the first question, here when the light, it passes from air to the glass, two different mediums, because it's passing through two different mediums, so the speed of the light of waves, it will decrease, it will slow down. Question number 4. The figure shows an object OB of height 2 centimeters in front of a converging lens. The principal focus of the lens are labeled F, okay, and image of OB will be formed to the right of the lens. A. Copy the figure and draw two rays from the top of the object B, which passes through the lens and go to the image. Here, to draw rays, okay, we said we have we call them standard rays. Standard rays, how we will do it? We will draw the first one from B. It goes to a straight line. It goes in a straight line which is parallel to the principal axis. Okay, it goes straight and then it will bend. It passes through the principal focus through this F. Another one, we will draw it from B, from the top of it. It passes straight through the center of the lens, and we will see the two rays. The two rays will meet at a specific point. This specific point, it represents what? It represents the image, the position of the image. So here it's the way. Firstly, as we said, from the top of this object, we will draw a line. This line, it should be straight and parallel to the principal axis, okay? And then another line from here, it should pass through F and goes straight. Then another line from the top of the object, it will go straight through the center of the lens. And now, as you can see, what happened, these two lines, they met at this point. And here it is the image. As you can see, the image, it's what? It's inverted, and also the size of it, it's bigger. B, draw the image formed, label this image I, and measure its size. Here it's the image, we will label it I. The size of it, as you can see, here it was 2 centimeters. It means each square it's 1 centimeter. Here it is 1, 2, 3. 3 centimeters. Question number 5. The diagram shows a converging lens forming a real image of an illuminated object. State 2 things that happen to the image when the object is moved toward F. Here we have object, and it says when you will move this object toward this F, okay, what will happen to the image? Now, when you will move the object toward the lens or toward the F, what will happen? The image here, it will be farther from the lens. When it will be farther, also what will happen? The size of it, it will change. So the image, it will be farther from lens, and also it will be larger. Question number 6. The diagram shows an object O here placed in front of a convex lens, and the passage of 2 rays from the top of the object through the lens. Copy and complete the diagram using the dimensions given to show where the image is formed. Here it's the way to draw the virtual image. What you will do, you will draw 2 lines. These lines, it should be straight from this point, okay? For example, here is the first one. And another line straight to this one. As you can see, these 2 lines, 2 straight lines, they will meet at a point. So this point, it's what? It's the image. This point is the image. B. State 2 properties of the image. If we will take a look on the image, how it is the image. Firstly, because it's virtual, see, look at the arrow, okay? The tip of the arrow. Both of them are at the top. So now this image, it is what? It is upright. It's not like the one that, like this one. This one, when we draw this one, how it is the direction of the arrow, it's upside down, okay? This here, it's inverted, but here the image, it's what? It is upright. And also, if you look at the size of it, it's what? It is magnified. It is bigger, okay? C. Use the information from the complete diagram and the equation. Linear magnification equals to height of the image or over height of the object to calculate the magnification produced by the lens. Now, how to solve this question? Here, height of image. How much is the height of image? You will measure it by using a ruler and you will find the height of the image and over the height of the object. Also, you will measure the height of the object. Then what you will do, you will divide the height of image over the height of the object. Question number 7. A. We have A and B. In the diagrams above, rays of light strike a mirror and one end of an optical fiber. Copy and complete the diagrams to show what will happen to each of the rays. Here in A, what will happen? Because it's a mirror, now when this light it strikes the mirror, so the light it will reflect. But how it will reflect? It will reflect with the same angle. What's that mean? A ray reflected at the same angle as it strikes it. And for example, we will see how much it's the angle here. If it's 20, so also this one, it should be 20, 30, 30, 40, 40. So the angle, it should be equal. B, because it's optical fiber, so what will happen? It will start in this way. It will start bending in this way, okay? Because in optic fiber, we said, what do we have? We have totally internally reflecting, okay? So, and it will keep going in this way. B, it says, which diagram shows an example of total internal reflection? Of course, the example, it is B. Here, the optical fiber. C. Give two practical uses of optical fibers. For what do we use optical fibers? As we mentioned before, we said we can use it for telephones and also use it for endoscope. Endoscope, which is looking inside the human organ. D. The light in each ray is monochromatic. What does this mean? What do you mean by the word monochromatic, or its example for monochromatic? It's the light that it comes from laser. So the meaning of monochromatic is it have a single wavelength. Question 8b. Draw a diagram to show the approximate direction the ray will take in the glass if the angle of incidence is 45 degrees and calculate the angle of refraction. The diagram, it will be in this way. Firstly, you will have this line. It shows the line between the line that it separates the two surfaces, which it's air and glass. Here it will be air at the top, and here it will be glass. Now, because the light it's passing from one medium to another medium, or it's passing through two different mediums, so what will happen? Of course, the light, it will bend, it will refract. But how much it will refract? If here, okay, this, it will be in the incident ray, okay, here the angle of it, it's 45. So then we will draw the normal, and because it's moving from air to glass, so it will, the line, it will bend toward the normal. So now we finish drawing the diagram. Now what do we need to do? We need to calculate the angle of refraction. To find the angle of refraction, we will use this formula or this equation. This equation, it says refractive index equals to sine incidence over sine refraction. Now, refractive index, it's already given in the question, it's 1.5 equals to sine incidence, also it's here, this one, it's 45 degrees over sine refraction, we want to find it. Now, by doing the calculations, we will get this one. The sine of 45 degrees by using calculator, it's 0.7. Okay. Now, sine refraction equals to, if you will divide 0.7 over 1.5, you will get 0.466. Now, what you will do, this number, you will convert it into angle. So you will take the sine of this number. When you will use calculator, you will see that the sine of 0.466, it's equal to 28 degrees. So the angle of refraction, it is 28 degrees. Question 9. Question 9, we will solve C, the math question. Question 9C, it says the speed of light is 3 times 10 to the power of 8 meter per second. Calculate the frequency of yellow light of wavelength, which is 6 times 10 to the power minus 7 meter. Okay, here what do we have? The information that we have speed of light and we have the wavelength. How we can find the frequency? We have a formula from last unit. The formula is speed equal to frequency times wavelength. Now, what do you mean by speed here? It's speed of light. Okay, speed of light, it's already given. It's 3 times 10 to the power of 8. Frequency, we want to find it, times the wavelength. The wavelength of the light, which is here, it's given. It's 6 times 10 to the power minus 7 power. Now, by doing the calculations, you will find that frequency it's equal to 5 times 10 to the power of 40. So this is the answer for question 9C. Question 10 will be your task. Question 10, it's same as question 9. You will use the same formula and you can apply the same information of question 9 on question number 10. And also question 11, it will be your task. Dear students, that was everything for this lesson. I hope you got benefit from it. Try to solve that task that I said, the questions that I mentioned. If you will face any problems, any challenges with these questions, please don't hesitate to write a comment. I will answer you back. Thank you and have a good day.